Most CAD applications provide a direct manipulation interaction paradigm to communicate with a user. Direct manipulation allows users to modify the models directly in the view. It provides a permanent representation of the objects that the user is modifying. Direct manipulation provides physical actions to perform modifications such as clicks, pointer movements, or drag and drop. The design process is incremental, and operations are reversible with immediate feedback for users to assess the impact of their modifications. A less popular approach follows a programming-based interaction paradigm. Differently than direct manipulation, in programming-based CAD applications, the models are fully described through coded instructions in a programming language. The application provides a code editor, either textual or graphic, to create scripts. It also provides a viewport to render the model after compilation for visual validation. Programming provides valuable features such as precision, easy way to perform repetitive actions, abstraction, and version control. Among the vast offer of CAD applications for different purposes, most of them follow a direct manipulation interaction and very few follow a programming-based paradigm. Some of the applications providing direct manipulation interactions allows scripting to perform specific actions. For instance, FreeCAD is a CAD application where users model in the view with direct manipulation interactions. It also allows users to execute Python in a text editor to edit the model. However, we do not consider these cases under the definition of programming-based CAD, since code executes specific actions rather than fully describing the model, as it happens in programming-based CAD applications. We focus our investigation in the programming-based paradigm. Specifically, we concentrated in a field where programming-based CAD applications are arguably popular, 3D printing. When looking at the literature searching about CAD applications challenges in the field of 3D printing, we quickly find that research has focused mostly in direct manipulation challenges with insights that are not applicable to programming-based CAD applications. For instance, some previous research has looked into problems that users face when measuring physical dimensions, transferring into a CAD application, and using this information in a design. Some of the identified challenges using information in the design are strongly related on difficulties using the interaction paradigm, such as errors when editing objects in the view due to camera handling. Critically, there is a lack of understanding on the problems of programming-based CAD users and applications. This paper aims to understand the motivation and challenges that programming-based users face in the field of 3D printing. To answer this question and better understand user motivations and challenges, we went to the source, the users. OpenSCAD is arguably the most popular programming-based CAD application in general, and provides a similar workflow than other programming-based CAD applications, so we use it for our study. We recruited 20 participants, OpenSCAD users in research laboratories and social media network for an interview. We asked questions related to their experience with other CAD applications, their design process with OpenSCAD, and their workflow designing for 3D printing. Some of the questions included their previous experience designing with direct manipulation CAD applications, and their perspective on the advantages and disadvantages between direct manipulation and programming-based CAD applications. We also included questions about their motivations of using OpenSCAD and the major difficulties they find during the design process. Regarding the 3D printing process, we included questions about the process, including their strategies and difficulties to measure physical dimensions to use them in programming-based CAD applications. Our paper includes the complete questionnaire in the appendix. We also asked participants to complete a hands-on exercise. We asked them to bring one of their previous OpenSCAD models to discuss it. Then, we asked them to perform an exercise replicating a repetitive action that users do when designing. We pointed a specific part in the view and asked them to locate the code statement that creates that part. We also asked participants to think aloud so we could understand the thinking process. We took notes of their answers and of the exercise behaviors, strategies, and common errors in the hands-on exercise. With this information, we conducted an iterative reflexive thematic analysis. To start, a first coder carried out an inductive thematic analysis to create a codebook. Then, a second coder used the codebook to perform a deductive thematic analysis. We contrast both results to verify intercoded agreement through the coherence cap as index. Both coders discuss differences and refine the codebook by adding, merging, modifying, or deleting codes. Then, the interviews were recoded with the new codebook. We iterated in the process 3 times. We started with 10 interviews in the first iterations, 5 in the second, and 5 in the third to complete all 20 interviews. At the end, we obtained a moderate agreement index. We grouped the codes around the core concept to establish themes. We identified 3 themes as a result. The first one is related to the programming-based CAD user's profile. The second one describes identified challenges in the design process. And the third one is related to 3D printing challenges. For the first theme, we coded 59 segments with 22 codes grouped in 9 subthemes. We found aspects related to their profile and motivations of users in programming-based CAD applications. For instance, all participants were programming-oriented users with some experience in programming. These users find programming-based CAD very convenient to create abstract and complex geometry, for instance, to create fractal geometries for robotic projects. Most of them mentioned having issues in understanding the workflow in direct manipulation applications. More details on this and other insights about the profile of programming-based CAD users can be found in our paper. The second and biggest theme is related to design challenges. We coded 632 segments with 193 codes grouped in 80 subthemes. One of our findings is the precision paradox. Participants mentioned that one of the advantages of programming is that it makes easy to achieve precision through the use of mathematical and programming expressions. However, they also mentioned that these applications doesn't have means to verify that the result was satisfactory. For instance, in this example, we highlighted code that creates 2 holes highlighted in the view. Although visually a user can perceive that the holes are well placed, it is not possible to verify it by measuring the distance between them, for example. Programming-based CAD applications offer limited resources to do this type of verifications. To confirm distances, users mentioned several strategies including echoing expressions in consoles or trial and error strategies. Other common challenge we found is the difficulty in relating the code and the view. In programming-based CAD, users model in one space, the code, and verify in another, the view. They need to mentally connect these 2 spaces with no assistance, which is challenging. For instance, given a part in the view that needs to be modified, the user needs to locate the correct code statement before modifying the model. This is normally done by reading the code carefully and trial and error strategies. Moreover, if the user wants to confirm where is the exact contribution of a code statement, users normally do trial and error strategies such as changing parameters or commenting code statements seeking visual confirmation. Similarly, the disconnection between the 2 spaces, code and view, makes the creation of a spatial transformation difficult because users must mentally connect the 3D space and its system of coordinates with the code statement. It is very common to apply transformations that modify the coordinate system in a specific block of code. In these cases, creating a new transformation anticipating its impact is challenging. For instance, to apply a new translate in our example, the user needs to understand the current system of coordinates to anticipate the impact of a new translate mentally. It is not easy to know what parameter needs to be changed to move the object in the direction that the user wants. Although participants had a programming background, some of them mentioned not having good math skills, which is necessary to create expressions to define shapes and transformations. Participants said this task is usually challenging and time-consuming. As depicted in the example, some expressions can be difficult. Geometric properties such as sizes and positions are defined in terms of other objects' geometric properties. Thus, mathematical expressions become more difficult with complex models. Other challenge mentioned by the participants is the difficulty to create curves and organic shapes with programming-based CAD applications. For instance, OpenSCAD doesn't offer easy ways to do these geometries. We found that some problems are a consequence of the disconnection between the code and the view that programming-based CAD applications present. All the design is done in the code, while the view is only used for validation. This forces users to mentally connect both spaces in a high-demanding task. We discussed possible approaches for future work that can address these and other design challenges described in detail in our paper. Printing challenges theme included 92 code segments with 51 codes grouped in 20 subthemes. Participants mentioned that fabricating is a multi-part hobby that can be split into 3 different hobbies: design, customization of the printer, and the printing process itself. Most of the participants said that there is no way to validate that the design will fulfill the requirements once it's printed. There are many variables involved, such as the materials, configurations and quality of the printer, and even the ambient temperature. This forces users to do test prints to validate results before printing the final result. They also commented on the role of model store on websites. Participants felt that it is not possible to find real customizable objects, but they seek inspiration in this type of websites. For more details and other challenges, please refer to our paper. In brief, we interviewed programming-based CAD users to provide a comprehensive understanding on their motivations and their design and printing challenges. Our findings are not limited to OpenSCAD, but can inform on the design on other CAD applications. This contribution is potentially the foundation of future work that guide the design of CAD applications as discussed in the paper. Thank you.